Good morning, everyone. This is May 8th, 2017, a Monday, and I'm here to start a series of videos called STEM 2020, a new playlist on YouTube. STEM 2020, that arises out of some discussion on the math forum where I've been continuing to push for a way of teaching math that includes learning to code. They help each other, these two topics or subjects. Math helps you learn code, and learning to code helps you learn the math concepts. That latter feedback cycle is sometimes neglected. We think that let's learn math first and then learn to code based on the math that we know, but actually seeing math concepts encoded can help you learn the math. So the learning to code is catalyzing math learning, and math learning is catalyzing learning to code. So it's kind of killing two virtual birds with one stone approach. And the language I'm using here is Python. I'm in the Anaconda distribution, which comes with this IDE, interactive development environment, called Spyder, S-P-Y-D-E-R. That's where I am right now. I'm just going to review kind of an overview form how I would teach some basics of both geometry and Python at the same time. I'm going to start with the end result, which is this circle class, which you see on my left. I can run this code on my left simply by hitting the green arrow. There's some testing code at the bottom, which I will ignore for now. What's true now is I've added this circle class to my interactive namespace on the right. So I can now create an instance of a circle. I can give birth to a circle object. The circle class is sort of the mother of all circles. It's the template. And each individual circle will have its own radius, its own identity, really. So on birth, when I call circle, it triggers what we call the constructor, the birth method. On birth, the radius is just by default 1. However, I can pass in any radius I want. Let's say I pass in a radius of 2 in this case. I have now created a circle object. It has an area. It has a perimeter, which actually I call that circumference, and it's actually going to be the same in this case. If you know, the 2 pi r and pi r squared are going to be the same number. Now, what's interesting here is I can change any of these three attributes, radius, area, and circumference, and have the other two change automatically, because any one of them is enough to determine everything else. So if I know, for example, that I have, say, 20 feet of fencing, and that's the determining factor. The fencing is somewhat expensive, and I want to use it all. I don't want to waste any. And I don't really care. I'm making a circular garden, let's say, and I don't really care exactly what the radius is. I'm curious, though, as to what it will be and the area. But mainly, I just want to use my 20 feet of fencing. So I can set the circumference to 20, and then ask, let's say it's in feet. Okay, so the radius will be a little over 3 feet. And what will the area of this garden be in square feet? It'll be about 31 square feet. So 32, I should say, to round it up. So that's an interesting way of having objects interact, where you can just assign one attribute and the others set automatically. It's not just applicable to circles. Even in the world of geometry, I have a tetra book, for example, which is a tetrahedron derived shape that I'll talk about that in another video. I'll look forward to that. In this case, let's just focus on the circle and see how it's implemented. How can we get away with just assigning attributes and yet causing these computations to go on behind the scenes? That's done with what's called property decorator. And what I'm going to do here is show how you use the property and then look behind the scenes at some code that emulates the property. This is taken directly from the Python documentation, and it's not pseudocode. It actually does exactly what the built-in property does. But the current version of Circle, the module, which is called circle2.py, I've commented out on line 16 the importing of the property class I just looked at, but I can uncomment this, and instead of using the built-in property, lowercase property, I can bring in from model property exactly this class and rename it to lowercase property as I import it. This is how the import statement looks. So I'm bringing in a class called property, renaming it to lowercase property, and now that's going to be doing all the work that we see further down in terms of decorating. Immediately, this looks strange if you've programmed in Python much, in that we are allowed to have the same methods more than once in the same class. That's perfectly okay in some languages as long as the signature is different, but in Python we really don't do this, except here we can do it. How do we get away with it? How can we have two radius methods, two area methods, and two circumference methods? Well, we need to establish setter and getter methods for these attributes, and that's what we're doing here. When we set the circumference, like O circumference equals 1, small circle, that's got to trigger some stuff that will make the radius recompute. So I have self.radius equals the value passed in divided by 2 times pi. However, setting the radius is in turn going to trigger the radius setter, which is another method, which stores the radius in a sort of private variable called underline radius, and then immediately computes the area and corresponding circumference. Now the circumference we have already just set, so in a way this looks redundant, but anytime we set the radius, we're going to have to set the circumference, because it might be that we're setting the radius directly. So I might say, let's just check the radius now. It's 0.159, 0.16 more or less. If I set the radius to 10, that's going to run this method called radius setter. Actually, the method is called radius, but as I'm going to show you in the code in a second, it's going to trigger the setter. And we're going to therefore have a new circumference and a new area as a result. So on the outside, the API I'm providing the user is simple assignment to attributes. There's no method calls here. Even though we have methods over on the left, because they're decorated, they're going to behave as attributes. Now, how do we get this magic? What is it about this decorator that makes it work this way? Well, as a side result, or side trip, or tangent, I would drop into another module, another piece of Python source code. This one's called dogma.py. And here I go over what's called descriptor syntax. Descriptor classes implement at least some of the set, get, delete protocol, where we use underscore set, underscore get. And by underscore, I mean we have underscores on both sides of these words. These are what we call special names in Python. It comes with a bunch. You don't make these up. They come with the language. And in the case of set and get, you're creating objects that pay close attention to when their values are being set or gotten. And in this example, I've created a small class hierarchy, a creature, which takes a data class instance and a non-data class instance at the class level, color and age. They're both stored at the class level. And these actually, because of inheritance, are going to take precedence. They're going to be what color and age refer to because of their being setters because of there being descriptors, I should say. So if I create a dog, O equals, let's call it object equals, well, first I have to run this code just to make these classes available in my namespace. So let's say ODog for an instance of a dog. Let's give birth to a dog. Use a very creative name for your dog, such as Rover. It looks like a set method got run already because color is one of these descriptors. It's being inherited from the creature class, and it's triggering the set method just because here I assign the color brown. So instead of going straight into the instance dictionary the way you may expect with Python, if you know Python well, every instance has its own little dictionary, and that is being set, but not directly. It's being set because the set method inside of data is being passed automatically the instance that we're talking about. In other words, the dog instance that we're talking about. And I use that to set the attribute. And the attribute is being remembered from initialization. When we first created color, I passed in the word color. When we created the class level object called color, at that very point I said, okay, you're going to be named color. Now there are ways to get that directly by studying the content of creature, and David Beasley has some good videos on how we can get less verbose at this point. But I'm just going to leave it at this level and now switch to talking about the cat. The cat I don't inherit from creature, but I do use the same data and non-data descriptors as decorators, meaning it's going to swallow up these methods underneath and feed them into init, where it's going to extract a name because they're functions. These are not strings. In the earlier case, I passed in strings, and so it sucked the name directly from the argument. But now it's going to absorb the name from the function being decorated, or method being decorated, color and age respectively. And because of that, the cat variables are going to behave somewhat the same way. I'm going to say oCat equals cat, let's call it Zeus, and now oCat color. Notice the method does nothing at all, but because it's been swallowed up into data and turned into one of these data instances, it's going to run that get method belonging to data. And at that point, the cat's instance dictionary is being updated with the correct information. So if I look oCat at the dictionary associated with that particular instance, the name is now Zeus, and the color is not set yet because I've only asked for the color. I haven't tried to assign a color. So let's say this is a gray cat. At this point, the set method runs, and now we have what I expect in the dictionary. The color has been added, but only because the set method ran, because actually the color method does nothing whatsoever all by itself. Now, how I explain decorators is in this Jupyter Notebook, I use the metaphor of being abducted. You can see in the source code here and in the picture, the thing about being abducted is you come back as you. You've just been changed somehow. You're still you, but there's something, maybe a special mark has been set to true, like a tattoo or something. There's something about you that is no longer what was, but it's still you, we could say. And that's kind of how decorators work. They suck in whatever's underneath and return a callable of the same name. Kind of, you could say, an imposter in a way, a replacement, a substitute. So we suck in color and get back something called color that actually is now more complicated because it's an instance of the data class. So once you go over setters and getters in some detail, or set and get, the descriptor protocol, then you can start to tackle this source code which emulates the property. It's working source code directly from the documentation that says if property were written in pure Python, this is how it would be written. And it's in studying this code that we come to a deeper appreciation for how properties work. What I do is go up to circle and uncomment on line 16 the import statement that brings in this class and now changes its name to lowercase property, thereby overriding the built-in. It's purple because this IDE recognizes built-ins and says, oh, that's a pretty important word. Are you sure you want to override it? Yeah, I want to override it with this new class called property. We'll call that property instead. So when I run the code, I'm trying to show that the exact same behavior comes out as a result. So let's look at what happens. When I decorate the radius with @property, you go back and see that you're sucking in a method, the getter, and assigning that to self.fget. The very first thing right underneath the @property is the method you need to get the radius, which is going to be this private variable underline radius. Okay. Now further down, and this looks strange, we're allowed to have the same method, the same named method, different method but with the same name. However, we decorate it differently this time, and that's because this radius has been abducted. It's been sucked into the UFO and spit back as radius, but now really it's an instance of a property, so it's quite complicated. And one of the methods of properties is setter. So because radius under the hood is now a property, I can use the radius.setter method, which does what? Creates another property object, but by passing what's already known about the current property object. So it passes self.fget onwards. We already set that earlier with @property. Now we're passing in the setter as our new argument. See, fset is the only thing coming in. So in decorating radius a second time, you could say, we are elaborating on a property that we'd gotten the ball rolling on before. And now we're just saying, okay, we know what the getter is already, here's the setter. And I do the same with area and circumference. I define setters and getters on both of these, and they behave the way they do because properties are also descriptors. They implement the set and get methods, meaning paying very close attention to when they are changed. And in this case, changing them triggers what we've saved as the setter and getter methods. You can see how fset and fget are being run in response to get and set. So this isn't a complete lesson. In other words, it might take somewhat longer to actually go through all this with your class, but I think it's a great way to synthesize and synergize what I would consider intermediate Python, this is not beginner Python, with, say, high school level math, and the idea of interconnected features of geometric objects, where if you set one parameter, you automatically get the others. I believe Raymond Hettinger uses the same idea, circle idea. You could use triangles, or as I mentioned before, I have a tetrahedron book with one page. It's got two book covers open, flat, triangular book covers, and one page that oscillates between those two book covers. And if you just set like the dihedral angle or the length from tip to book cover tip, page tip to book cover, any of these parameters that you set will automatically determine all the other parameters, including the area or the volume of those two tetrahedrons, where you have this flap going back and forth. You've got two complementary tetrahedrons. We'll talk about that in another video in my STEM 2020 series. I hope that was elucidating. I'll put some information in the comments about where you can get the files that I've been showing. Have a good rest of your day. Talk to you soon.